Basically, guys, welcome back to my YouTube channel. I'm gonna try to do this video today. Basically, this video is something called the times now. A as I, and I as A. This stands for infrastructure as architecture. Which are the same thing. But just they mean the same thing. They are the same thing. When basically the only context is different. It's just what you use it for. So if you want to use A as I, use the repository. But the same thing. That's architecture as infrastructure and infrastructure as architecture. You want on the OB Nexus GitHub repository. That's github.com/OBI /A as I or I as A. Okay, so what is this? Infrastructure is architecture. The object is solid. The infrastructure, the meaning, the foundation, it can be interpreted. Directed symbiotic evolution. The thing about this is like they are meant to be active systems that do something. They're meant to be activate. They're meant to be active architectures, like active modeling of growth of based on dialectic symbolic evolution, like an architecture that can evolve. Like based on the net gated phase. Like the actual silicon. For example, directed symbolic evolution, random access memory, or diagram. But DRAM can evolve. But if I flash that into the firmware of the motherboard of the BIOS, that has to contain the hardware, and the hardware must be to evolve the software, and vice versa. That's what it's to. Now, basically, the thing is like the NeuroDivernget first. Basically, these are kind of systems that are gonna be component driven. Basically, something called Semantic Versioning X, which is my model of semantic versioning extension to it. Hence the semantic version extended framework. But I'll come back to that. Let me just try to clarify some things. So this is called an NLM, the Simply Language Model. This is called NLM underscore framework. But it's like an assembly language. This is like you got the most language, the root languages, but the root languages are like assembly, very old languages like Arabic, Hindi, all the all the root languages that give us Latin words that the Roman Empire that gave us the modern English. That's called the root languages. Things that people know the origin, root the anchor, like Igbo, Nsibidi, Biafra, my history. This is called an LLM model. There's two models to this. You got the NLM framework, which is a language. They got underscore NLM underscore Atlas. Basically, the NLM underscore framework and LLM Atlas are the same thing, but the NLM Atlas framework is focused on the Nsibidi inscribers, like Nsibidi itself, cultural Nsibidi. Based on the model, the goal is to have something called a semantic version in X, which is like a packaging manager. Simva X is a packaging manager for, but semantic version extended. So what you do in semantic version extended, you have like a mapping, a bi-direction cohesive mapping. So we have like a major, a major dot, experimental, dot LTS or stable, depending on how you wanna call it. The stable releases and they have major dot experimental that stable, stable, and the legacy. Legacy is the one that's old, very old. Based on monogot, like mono, like the one mono means just one, just one endpoint, one ecosystem, like Node.js, pip, Python package indexing, go golfer, package manager, Java XML, Java POM the XML, the POM package manager for Java. All these are just monogot systems. Then you got polyglot, like you just shared alphabet, and then you got the hybrid, across the ecosystem, which can be active or passive depending on the interaction layer you want for that system. But I recommend active systems now because systems will know the state of and gonna update themselves, without too much hassle. And roll back if necessary before the human even notices. That's the goal of the active model, even just to make sure that the human can work fluently without any interruption in like doing what the domain to do, like a built-in surveillance of the state of propagation. So the NLM framework is based on the principle Very important. So you got the right axis, which is just the factual stuff, the facts. Then you got the left axis of that's the fictional. Now this axis, factual and fictional, are different because they are they can be the more true something is, the less fiction the made up it is. And then that's like the language itself. So if I speak a language, I sold my car. I don't have a car. That's a fictional. I am dark in complexion, etc. etc. My eyes are brown, which they are, but you can't see them. Are they? No, they're black, brown, grey. Anyone they are, I can't see them. And then my hair is soft and curly. Those are all true, etc. etc. I'm handsome. I know I'm handsome. Now that's it. Like now I can extend this to formal. Now formal. The formal will. Oh, my battery's gonna die. It's gonna die again. It lose that this time, day, night. I'm making the second time I'm making this video because I lost the first one. Sorry guys, let me just show my battery. So the thing I'm saying, charging is so basically basically go to formal one, the formal and informal one. So I can say I am the greatest man of all time. I can be like in a formal setting. My hair is I'm dark in complexion. My nose is round. And I would love to eat my burgers, which I do, because the genes are. I get like sick. I don't take medication, which I do like to do my burgers. I'll say again because I don't take medication. And it goes to informal. The informal one is like the opposite one. I just speak to my friends. Yo, let me eat my burgers. No meds needed. No vaccine. And then you got the Z. Based on phenomenological represents. This is where the senses come in. Because if the language everything now the senses for PLP measure directed symbiotic evolution principle. Like how well I project myself to the outside world. Like how well my persona is accurately reflected into someone else's internal world. You know, um, like how 95.4 I push out and that gets how I send information coherently and get based on 0.05 metric for 100% coherence for what I'm about to do. The goal of me is to project my message to the outside world, like in Arabic. There's an Arabic programming language, Symbidy model, but this is a model of a Symbidy language model, like how a system programmatically does something. Now, the extension to the Symbidy model called the Symbidy NLM Atlas. Now, the thing about this, you have to show that the verb noun, which is the verb, is like the action. The verb is like the doing word. I'm walking and talking, based on bi-directionalness. But I'm saying to you that the element framework is really there's language, there's in Arabic, there's in French we have like a model of this. It's called prefix notation. Let me just write it down here. Because it's called a postfix. There's not basically there's a way that human language evolves to this Arabic. If you know Arabic, there's there's like a way to have a prefix post prefix my if you want to say like I'm going to the library, the library or library. But in Arabic we have like a way of saying it. There's three tenses to it, and that tense is used to can swapped out like X Y Z. Like the gates is X Y. The goal of this is to reduce the language into something someone with a lisp can say. That's how why it's formed. Arabic, French doesn't have that. Basically, someone has a lisp and they have this ability. They will not be able to speak a language coherently because say I fell downstairs and I hit my nose, and then I can use my speak properly. I have a lisp, or I was born with a lisp, like a parenthesis, like a P, like like an F. That's the phonetic. That's what a lisp is. It's a mispronunciation, It's more of a taxonomy miscategorization of the mind, of the processual syndrome than the actual problem. Because the thing about the language is that the language is not good enough for that person demographic to pull it down. Because there's not enough information. It's like a Russian person saying internet. The internet is not the word; it's internet. But the internet is made by British. So it's like it's English, so she's not familiar with that language. But she has a way of saying it in that language that we may not understand in a bi-directional way, and that's why the NLM Atlas matters. The NLM Atlas, or what called the Symbidy language model Atlas, is just a bi-directional top-down, bottom-up reasoning protocol. Depending on, it's not really top down. It's no power dominant. It's just like how much can I pull in my world? Because there's a DAG that resolves it, but it's sort of like an equilibrium to maximize the ease of use. That's what I say top down. Let's go top down. Let's go to bi-directional resolution. For it. Yes, that's a bi-directional resolution. So we got that. Yes. So basically, that's what I'm saying. So the thing I'm saying to this, I'm gonna go back to my point now. The thing about architecture and infrastructure architecture is based on semantic function X. I'm building computers this year for myself. They're called Directed Symbiotic Evolution, hardware and software. Basically, they use the semantic version in X mapping in silicon, like the computer keypad will be directed. Basically, the keypad is active. It knows you're gonna type next. It knows how to interact with your senses. More specifically, one project I want to work on is like a retina scanning system. Say I have a camera and a retina scanner, and I open my laptop and I then press a button, and then the retina orientates it's like a 360 retina. It looks at my own retina, and I don't have to just put my face there, and then looks at my eyes like this. It can be like this, and it come like this. I don't really mind, but the goal is for the computer to read my retina and authenticate me to the system. My computer can start interacting with it, whether by hand. I don't want to keep typing password. What my retina can do, the cursor. The retina can be a cursor, based on active. And just basically, once it looks at me, and then I blink with this eye, it should be able to activate. Because I don't like stretching myself. My eyes basically, it's gonna reduce my body strength because I just have to do it myself. So that's kind of system I'm building for my directed structure system. The goal of this system, directed symbiotic contract between my retina as an authentication and my retinas as a cursor, and my retina as a navigation. Like cursor navigation is to make it isomorphic to that individual. Since someone's retina cannot be controlling my computer. For example, it's not for security measure as well. You can basically use it for authentication. You can have a backup card or backup password or backup pin, if I like. But the goal of that is just ease of use, ease of use. So basically, the NLM Atlas is like for geometric function core library. What NLM Atlas provides for geocode is like it knows how to navigate something. Like the Atlas is based on the system of the architecture that's gonna evolve, like the directed symbiotic RAM, directed symbiotic solid state drive, to free up the corruption of the system. So the program cannot be corrupt. There's no program corruption. It's mitigated because the user's intent is statement intent expression is evaluated before the computer can even act. Observe and then consume. Observe because there's no error. That's why the observer is first. Because if the computer doesn't observe you first, it will not know you can consume. It will act without a judgment, and that's what's really bad to act. So basically, this is like trying to get the system to understand that the observer protocol 95.4 is more important than the consumer, the user, because the consumer of the web that is what is navigating on the keyboard, what is having the keyboard warm, what is watching you can observe more than, and that's how they build the next evolution of computers, because the computing systems now are fragile and weak, and they are prone to a lot of corruption, or digital or not, online or not, and they don't have like a error recovery protocol that you can that's language agnostic and user friendly, which is how to try to fix the computer to take action. So the goal of this is to have the keys know what you're literally gonna do, based on some kind of like format this preset, or like and the system can evolve and adapt to new systems, through polyglot means. The idea of this architecture I'm building is this. So the first thing to mitigate is ease of use. What does this use? Ease of use problem. So basically, no assumptions. We don't really assume stuff. We just interpret. We got like interprets like mechanic. We don't assume nothing about the user. We just interpret what it could mean. For example, the thing about the user is neurodivergent traits or systems assumption. Basically, you don't want users to assume. You want to give them more options. No assuming. So no assumptions made about the user's intent, like on the website and then. We just have to make it all no assumptions. All the power to the user. Basically, give them 5% power for control, and then that means like oh like essay and that's a 5.5. And they give you 6% of whatever is left because that'll be the system new infrastructure, new architecture infrastructure. The thing about this is like the ease of use is based on fear, uncertainty, and doubt. Then there's no fear. There's no fear. There should be no fear. There should be no uncertainty, and there's no doubt. The UI. That's dark psychology patterns. To get someone to force someone to do it. Basically, architecture is how we do, how we build, how we implement. It's not the question. It's not the implementation directly. It's how the silicon or the implementation is sound. It's more about soundness. Like the system is coherently knowing what to do. Directed instruction means like the system knows it's the path to take. If a user doesn't know, it's active. That's the term active. But the former term I call it is directed instruction. This directed instruction or directed symbiotic evolution, which means like the person is like actually interacting at the molecular level. Like it's something that can go wrong, but that's like for later. The directed instruction is good enough for now because it is open to interpretation. What the user action is. But the user is acting on it, but the direction instruction, a random action, you got a diagram or diepad, direction instruction keypad, etc. etc. You're gonna ask the 4 questions: what, why, 5, what, why, when, where, why. But you're not gonna how to what, how to why, how to when, how to do, how to not. There's how to X, how to Y, how to Z. Based on a given phenomenon. But the thing about this is to have the UI mitigate all that doubt, all that fear, all that uncertainty, before they even user clicks a button. Does an action because the user can then complete whatever the online process is, whatever they're meant to do online, whether or play a video game or not. The thing about this is the system must maintain like the coherence. Example, so major, minor, and patch, which are just not just major is like version 1. All that have the directory mapping to experimental LTS or long-term support and stable. LTS means long-term support and then or stable and legacy. Legacy one very old modules that maybe monoglot, polyglot, and hybrid depending on the infrastructure you want to need. So, or the architecture you want to use, IASA or ASI. So we basically got three minimalist design. So this is like the first one, the second principle. Now the third principle is the minimalist design. Let me check my thing. Just to go. Is it going? It's not recording. Yes, it's still recording. No, it's not recording. Let me just check. No, it is recording somewhere, but it's not paused, so it may not be recording. I think it's failed somewhere. It's still not recording. Okay, it is recording, guys. It's still recording. Thank you. So basically, guys, the idea of this minimalist design is like to have everything at the X gates. Like the X, reduce the problem reduction, make it easier. Don't complicate it. So basically, X gate is for unit testing, just modules. 95.4 Korean to 0.6, just bidirectionally. Invariant environment, bidirectional, variant stuff, things that the variants user expect from the user. Now, things you don't expect from the users, but that should be things that are foundational are invariant. You can't live without. That's what everyone will use. Now, it's not just it's not Mangala. Basically, everything invariant implemented must be for the NeuroDivernget, basically open sensory perception framework, and the anything that's not for the user is like it's basically it's just a need if everything's invariant, and it's a want if everything is on top. So basically, separate the classification from variant and invariant. Now the XYZ, X is unit testing, Y is integration, Z is system testing. Now system testing must work cohesively in that framework. In the management of CM architecture. The wireframe approach, like I create a wireframe, like I draw like a web page, like I have to do this. What you see is what you mean. What that means is like what I see, login, is what I mean. What do I mean by what I see? But that doesn't really make sense. That's just one interface. That's just one UI interaction area. When I write HTML code, CSS code, based on objects, which is heart or soul, polyglot library that's written in looks like Rift, but it's not looks like React, but it's not React. Basically, I uploaded React standard for Obix, but Obix is a hard US, but it's monoglot, polyglot, and hybrid, and that's why that exists for the UI layer. Because that can be cross contaminating components, and that's why that matters for Semotic version X. Now, Obix, OBIX is hot or so. So it works basically if a user is more in tune with what you see is what you mean. They can just pick the option, and that will be what you see. They can mean something when they type it, and they can code it up as developers. And what you see is what you get. Like what I see is what I'm acting on, and that's like HTML structure. Basically, the layers of HTML or UI is based on these two principles alone. You either adopt one or you leave one. But that's you have to pick two. Because the new divergence based on WAG, accessibility principles. But WAG is like that. But WAG is like more non-tuned with this. But the thing about this, what you see is what you mean. It's like that's more for coding, and then what you see is what you get. It's more for people that don't specialize, that don't use the stuff like third-party WordPress. But the problem with that, if you try to make one use the other, they don't work cohesively, and that's a big problem. So that's what you want to mitigate. That's what you want to remove. So markup, that's basically when you create a wireframe, whether it be like instead of being like a slicker for diagram. This is just the ease of use accessibility here. So this is ease of use accessibility here, here and here, and then you get this. So you see that? You see this? This is here. This is what I'm saying. So this is like the schema of it. As I is I is A. Here. What I'm saying is like the thing about this is personal disorder mitigation, fatigue, all the invariant of the fear, associated that you're trying to mitigate. So you're gonna have wireframe, then it's basically trying to integrate the next grade, into the design. So some people have been a wireframe for Obix website, like my own website, OBXS. I put this up. I put like where the image is gonna be based on UI philosophy and UX transition, and I think of the UX into the UI because I think of how the system is gonna flow naturally from UX UI. Those kind of things are very important because you just click a button, it comes to the next step. But the design of that system has to have the image in it too. So my constitution, where my house is, where I do business, it's about the design of the wireframe being intact in how we do it. So when I then update it next time, I don't have to struggle to stress my life up. And that's then because basically you gotta think about the next step, the design aspect, that architecture as infrastructure, or the infrastructure architecture by direction, whichever you do. Because if the wireframe is just the infrastructure, then the architecture has to be next anyway. Because they're the same thing. Just work the problem cohesively to resolve the issue, like the image updates, the system. Basically, you have to work them together to do it in one, not just one by itself. Then you got markup or prototype. So you got like the wireframe. Then you got the design, the architecture. Let me give you the infrastructure. You now you go go next to the markup. You got the markup, you got a markup. Now you design what architecture. You're gonna make up the markup like how the system will mark up in the Euro time, and the markup will be the what you see is what you mean, and what you see, what you mean is what you get, and that would require the infrastructure, the prototype of that design into infrastructure, and that's what's so flexible. And by direction, you got like a schema. Now the schema is very important. So like if I have a system that doesn't have a good schema or a clear schema, bi-directional contract, based on directory cyclic graph. Say I build directory structured RAM, the silicon, on my 3D printer here that I'm meant to be in Cambridge with, and I don't have that set up properly. I print my 3D printer. I print my RAM. I put my random access memory. And my random access memory then does what? The RAM doesn't be the same. Like the RAM is not the same. Like it comes out, but the schema, how I get it, the schema, the blueprint of the logic is not geometric, doesn't align with the maths. That's why I really prefer like schemas to mathematical equations, because I can evaluate a schema instinctively with my eyes. Oh, that works, and that's called a blueprint. So I can make a blueprint instead of like trying to write formulas into the silicon, because it's similar. Because basically you have to put the right proof structure to do it. So basically the same thing happens for the code. For the code, just have like a diagram, a model of how the system interacts with UI, user flow, you and the other system. Directed Semotic Evolution. Now, persistent mitigation, NeuroDivernget first. Basically, NeuroDivernget first, and integrity. Basically, the problem is to have the problems in the Z integration from Y. Basically, the Z Y is like integration of the system, how I use it cohesively. The whole component. Basically, how I use a diagram system, the hardware on my own silicon, on my own computer, how I put it in, how I load 8 GB memory of active state that will never fail me. How I use Directed Semotic Evolution to ensure there's a contract between my RAM and whatever RAM DDR RAM. But directed instruction DI is for evolvings, or directed system is based on active random access memory that know what they do when they act, when they do an operation. And store it 8 GB, 8 KB, 8 GB, doesn't matter, as long as they solve the problem and can free up the memory and to prevent fragmentation in other programs on my computer. So these are the computers I'm building. They know what they're doing. They feel they're sensory of where of the user's intent, because the senses are not really there. There is a show the overload is away from the user. Basically, the thing about this is the gates is special because they know what they do. Persona the development criteria. Basically, the idea is to make it very easy for people to do religious first, or life first, to focus on their life first, to actually reduce stress. Because if you have a 40 life, you cannot use stress. So basically, the thing about this is you have a touch, speak, sight. If you remember sight, the sight, my touch, how I interact with it at a mechanical level. It just feels like a boring system. There's no if this key vibrates, it will make me sense that I'm putting pressure on it, and I can mitigate the pressure. Those kind of feedback loops are very important. So when I say like a touch, I mean like a relay system, touch relay, speak relay. When I'm shouting, when I'm angry, and the system will be like, he's focused. He's and the system will know that I am here because I am here. But the system doesn't know that he has to try to it's fragmented one, but he has to try to understand that I am trying to complete a process. When I come up with a process, when I've done it on my own time, and that's why the relay systems are very important. Directed relay. But directed sequential evolution is very contract. And then you got the problem is that the thing is like computers are the gap in neurodivergent people. Listen, see here, the problem is the computation is limited because it's not accessible. There's something called there's an accessibility gap, especially for people who are in a less economically developed country. There's a big computing learning gap, and it should not be that way. It must not be that way. Because if everyone wants to be looked at as part of society, everyone wants to be equitable. Everyone wants to be like free of charge. That's why I believe in it. The discrimination is too much because the computer, people cannot work and do what they do on computer because they know what the computer is. But some people don't understand computers, not because they don't know, because they haven't given a chance to look at the world how it could be better. So this is what I'm saying. The thing about the systems, they're free of charge. They're meant to be expressing the intent of the system. The system wants to do it. So basically, the equity is like this. So I got an equity model here. Basically, say I'm 18 years old, and my brother is 16, my sister is 16, and my brother is 14 years old. But the minimum age requirement is 15 years old. Now, I can go to see a football game without any problem. My sister is 16, if she's 16, but she's short. She's short. So she's like seeing a football game, but she can't afford the first class. She can't afford the first class ticket, so she has to sit at the back of the football game. She's 15. She's 16 actually, and she's 16, and she should sit at the back, very back, because she wants to see the football game. But she won't see anything because she's like short-sighted. No, she's good sighted, but she wears glasses. But I don't know, but she can't see anything. That's discrimination. That's not equity. So the computer is equitable because then my brother who's 14 years old, maybe just hypothetically, then has to go to the game and sneak into the game, and when he gets caught, he'll be arrested and charged with a crime. whatever, because the system that was there to see the football game was never available. And then the law was broken because he's 14 years old, have to hold him, everything, and he doesn't want to be held. That's why he wanted to see the football games. Now, given the neurodivergent, that's what I'm saying to you. That's what the equity is. Equity is about personalized fairness. Like, if this problem was to solve, my brother, 14 years old, would be allowed to be in a football game at the very front because he is the youngest and the most vulnerable to see. Now, my sister can be at the front watching over my brother because she's 15 or 16, I don't know, 15 years old, and then she will be like watching my brother to do this to see how he interacts, and then there'll be no problem because she's at the front row seat too, and because she's a vulnerable young youth person because she's young, she's 15. Then I'm 18, I can sit anywhere I want, which it doesn't really matter if I don't have a problem, if you're divergent, as long as I am obeying with the stadium rules. What is this? Identity as an anchor. Yes, basically, I'm saying to you the thing about this, they have to have some kind of a directly symbolic version of retina scanning, because retina scanning is a thing, yes, but the technology is well behind because it's not actively modeling the unique code in the retina DNA that is not unique to everyone else unless you're a twin. Because retina is like allows you to it's really like a fingerprint. Yes, it's fingerprint, but it's for your eyes. It's for your unique eye ID. It's like it's in your eye. The retina cones see everything, but they are unique, so that you won't be blind. You have like a degradation of the eye because the eye is very important for you to see, and that's why you have like two eyes. If you don't know, because the retina ensures that the system is cohesive, and that's why everyone should know that it's unique. But that's unique and how when they move their eyes, they are using it to see in their own world view. If that's true. But that's for up to yes, they will see perceive themselves, which I'll say is true because I'm autistic. Eye tracker, retina scanner, and that's how the sensory is preserved. It's like it's meant to model your eyes, your things, who you are. This is what talking about computers that can be computer driven can basically so we can swap out the hardware, the software. They don't feel rigid when you type them. They feel like you own something. You're part of an ecosystem, part of the world around you. That's what the hybrid. Hybrid just means like monoglot, polyglot, and hybrid monoglot, polyglot, and hybrid systems. Hybrid directed like can be classical to quantum as long as the system code executes and works across those layers. It's hybrid. Directed instruction it can evolve. Like a binary and evolve like a ternary. It can evolve its state. It knows by evolve it can act. It can basically can have like what a computer tries to do based on what you interpreted, and it can interpret that state and do that thing, and then it can do that for everyone that has that trait of that or that a mind to do it. The thing about this is that the system must remain like a directly symbiotic. Or, if I'm speaking to someone that's basically directly symbiotic, it means like it's like the symbiote. It's I can talk to a Chinese person and the system will relay to me in English. I can talk to a Japanese I can talk to my friend in Igbo and the system will relay to them in Chinese. Vice versa. That's what symbiotic contract means between two parties, like two people that understand the concept of language but can't speak each other's language. That's why it's powerful to you guys, and that's what I want you guys to have. Everyone here should have that. Personal development, sharp. Okay. Thank you guys. Subscribe to my YouTube channel, and I hope you guys like this video. This video was about my masters, a lot of things actually, and a system that can evolve and adapt, and what does that call it? Sorry. But it's you guys should have a look at this video, and yes, one more thing. It's about cultural preservation. One more thing. Basically, I have a corruption model too. I almost forget. The corruption model is this. It's very good to have this model, guys. So basically, the thing about the system, when it doesn't get better for one person, it should get better for everyone. That's what I'm saying. So the corruption model presents this. So it's got a corruption model. So basically, the thing about systems in the monoglot, polyglot, and hybrid system is this is like a corruption model. So you see like all the zeros. These are like corrupt. Can be like so this should be a 0 to 1. This could be a 1-0. Basically, it's like there's a mismatch of the system, and the system gets loses some information, crashes some parts, segments of the system. But it can happen in this is actual system, if the thing gets misinterpretation of someone's action. So I'm saying to you, this encourages like a DAG matrix based on the as one for DAG restriction, directed Semotic Evolution construct. But the system with this DAG is to ensure that everyone in the node, which is either 0 or 1, have an actor model is treated with equity. This can be people too. In the DAG participating, or like because the system is like could decoherent when everyone is treated equal, when the party doesn't resolve itself. So this like diamond dependency DAG, like you can take this one for example, like a root artifact, like an animal, and this could be a animal of type cat and dog, and you can get a cat dog hybrid. But this is like a model of it because the system cannot resolve a library. So this is like a animal library called animal cat, animal dog. This should resolve to two independent libraries, lib cat or lib dog. But this is lib animal. So the thing about this is like when you try to use lib cat with dog, it doesn't know it misinterprets this layer. Do you want a dog or cat? Sorry, it could be the same dog, look animal dog, but the thing is this down, but it's like things that fragment things, basically the things you want to avoid when you're actually building libraries like this. Mono got plug, this kind of DAG resolution, we need to error because error is really big thing into the model. So when the system tries to revert, it can actually bring this one, hot swap. Basically the last one here, you have to hot swap it. Because it's gonna be a break anyway. Because when you try to use this one, this last one here, so you got the root one, which is like animal, and you create animal cat, animal dog, and this is cat dog here, and the user comes here and tries to use cat dog, but which type of animal, which is DAG animal. Now this cat dog is an animal, yes, but it doesn't know that the type is fragmented because there's no cat or dog relationship between a cat, which is a feline, and a dog, which is like a shepherd dog. They're two different breeds of animals. They have to keep them animals. So the way to resolve this is just to get rid of this library here, libcat dog, and ensure the user never comes across this program here. And that's what we have to resolve with a direction, so everything can evolve. So basically, this can hot swap this library here. These two libraries here are degree 2, or the cat or the dog, and ensure they do different things based on monoglots, polyglots, and hybrid schemas. How you define the schemas in real time. The goal of this is really to ensure the system is fluid and everyone is doing one more thing, the model, basically another thing, so basically this is another real one. So if you want to buy a house, 0 pence, free house, no council, 50 pence or £1. So if I get a free house, basically this house is like one free. This house is free, meant to be free. But I have to pay 1p. Because I'm corrupt already. Because I meant to get a free house, but I didn't get it. This is a 1p house. I think they give £60 million per human rights. How to care? £60,000. I get 599 million. And then you get 50 pence. Then I get 59.0 pence. And I get £1. That'll be 59,000 million. But this is just like think of it just like 60p, over 60p. If you don't over 60 pounds, 60 pounds, if you want. But the goal is for this system to because they don't want to give me a free house. They don't want to give me a free house, so it's not a free house like here. The free house is not there, so because I'm not autistic to them, they're not to them. So basically, the thing about this model is to basically the rich get richer, we get richer too, and everything comes to equilibrium. Everyone is sustained and happy, like it should be. And then this is based on open access distribution system. But the thing is the thing is corrupt because if I don't get a free house and I have to buy a house. If I don't get a free house, I have to buy a 50p house. And I buy a 50p house. Then they say no free house because this guy, autistic guy, bought a 50p house. So you can buy a 50p house and the system gets fucked up, messed up because the system messed up anyway. Because I bought a house, I didn't get a free house under the Hadware 2014. 1812k was broken. But what I'm saying, now you got the 50p house. Look, if you get a pound house, now they say you have to pay, and it gets better for the bad people and worse for the us people, the poor people, and the basket will be cut. The strand will be cut, and the poor rich get richer and the poor grow. That's what's happened already. So you should never give away your human rights. But you know, just messing with the council when I say this. But you know, I'm saying this true because you know I'm insulting them. No house. So you care out. Just do what's your job. But you know, the goal is to insult them. But because I'm not giving my human rights to them in any shape or form. Just insult them. Cause, you know, if I sue them, I'm gonna sue them 1p anyway. You know, for the 1p. Anyway, so I can get this on the, but that more than 1p on the tribunal. That's how corruption models. So I have to find ways the system can fragment itself based on active recovery or hot swap logic, which I'm trying to do for real world testing, which I've discovered with gating. Philosophy. So basically, you can have a schema that doesn't work. That's a defect. Based on how the way of the hop swap, based on active system, because you have to hop swap a lot. So you have to have like a system that knows how to resolve itself, knows how to hot swap when something is not busy, you know, and how to swap it coherently and ensure the system is updated when the user wakes up in the morning. And it gets better for everyone when you hot swap and change components around, whether it's physical, hardware, or like software, silicon, or like executable programs. Okay, thank you guys for watching this video. GitHub.com/open diagram with a C at the end, and directed Semotic Evolution. That's assembly language.